Okay. Okay. Thank you. Thank you for reminding me. Okay. Whatever I'm going to, usually in geometrical methods, we use 2 points A, B on the moving body, describe its location to determine the position of a rigid body. In case of analytical methods, it's preferable to use the moving coordinate frame. But there's no difference in between them because all you have to do is select 2 points on the x-axis, call this O prime as A, take another point over here at a certain distance, call it B. It will correspond to this moving coordinate frame, okay? So you can switch back and forth between that description and this description. There is no problem. But in analytical methods, it is easier to describe the moving body, the location of a moving body, saying, okay, it is at the J's position. The origin of the moving body is OJ prime. Origin of the reference coordinate frame is at OJ prime. And the x-axis is making an angle phi j with respect to x-axis of the reference frame, fixed reference frame. Okay, this is our fixed reference frame, and that is phi j. So I have 3 parameters, let me repeat, to describe the location of a rigid body in plane motion. One is the location of OJ prime given by the vector AJ, small aj. The other is this angle phi j. 3 parameters. 2 coordinates of AJ. AJ is a vector, planar vector, or in complex number, A plus IB, and the angle phi j. Let us consider a point AJ on the moving body. Here is a point AJ on the moving body at J's position. A is on the rigid body. At the J's position, relative to the fixed frame, it is AJ. Since A is a fixed point on the moving body, its coordinate will be Z. Z is equal to X plus IY. X and Y measured with respect to this moving frame, meaning X, I think I must have a pencil somewhere. Oh, where was it? Yeah. No, I'll draw. Okay, I drop X component and Y component of C is like this. Whereas X and Y component of capital Z, the location of that point AJ with respect to the frame, the fixed frame, can I draw straight line? Okay. It will be like this. Zj vector will be equal to AJ vector plus this Z vector, but it is Z vector is rotated by an angle phi j. Can you see? Z vector is measured with respect to the moving frame. So it is rotated by phi j. Rotation operator in complex number is multiplication of that vector with e to the I phi j. I think we have seen this. Am I correct? When you multiply a complex number with e to the I phi j, it is rotated. If you multiply a complex number by a scalar constant, it is stretching. It elongates the vector, does not change its direction. This is stretch rotation, we call it. E to the I phi j operation on Z is rotation of Z. If this XY movement coordinate frame was parallel to the reference frame, it will be A plus Z, no problem, as you can see. But if it is rotated, we multiply z with e to the I phi j. Zj will be equal to aj plus z e to the I phi j. If I have a case position, zk, at the case position, it will be ak. Aj is going to change. Z is not going to change. Z is measured. If A is the same point on the moving body, Z is the same. So in that case, phi k is the angular position of the moving frame at the case position. Zj and Zk. Aj plus Z e to the I phi j, Ak plus Z e to the I phi k. Now, if I take any point on the moving frame, it's going to have a location A1 in the first position, A2 in the second position, B1, B2. There is only one point on the moving body whose location is the same for the first position and the second position, or for the jth position and the kth position. That point is the pole. Because the pole, this pole, does not change its location. This point on the moving body does not change its position when moved from the first to the second. It is fixed for these two positions. So that means Zj will be equal to Zk only if that point, Aj we called, is Pjk. I'm calling Jk, call it 1, 2, call it 2, 3, because I'm going to generalize this to more positions. Right now we are discussing 2 positions, but later it will be going up to 5. So Jk can be 1, 2, 3, 4, etc. Now, Zj will be equal to Zk only if that point is the pole. We call it capital Pjk. And in that case, Z, we shall call it Pjk, measurement of the pole from the moving reference frame. It is small Pjk. It is the only point on the moving body which has this characteristics, the same position for 2 positions. Now what we do is, if that is the case, we equate Zj and Zk. We obtain Aj plus Pjk e to the I phi j is equal to Ak plus Pjk e to the I phi k. Solve for Pjk. Small Pjk, this vector, is equal to, Pjk is equal to Ak minus Aj, Ak, Aj, Ak, the difference, divided by e to the I phi j minus e to the I phi k. This is the location of the pole with respect to the moving frame. Now, substitute that small Pjk into one of these equations, Zj or Zk, and solve. You have Pjk equal, okay, Zj is equal to Zk, Pjk, Aj plus Pjk e to the I phi j. Substitute Pjk into this equation. Capital Pjk now will be equal to capital Pjk, Ak e to the I phi j minus Aj e to the I phi k, e to the I phi j minus e to the I phi k. Location of the pole on the fixed frame. This is the location of the pole on the fixed frame. This is what you measure. This Pjk is the measured from moving reference frame. This capital Pjk is measured from the fixed reference frame. I'll tell you one thing. If the moving and fixed frames are coincident at the first position, the two will give you the same result in the first position only. Location of the fall in the fixed frame is this equation. AK, AJ are complex numbers. E to I phi j is, as you remember, cosine phi j plus I sine phi j, according to Euler's theorem. Usually, in the literature, you will see E to I phi j written E sub j, E to I phi k written as E sub k, to simplify the notation, writing these equations. We obtain the location of the pole on the moving frame and the location of the pole on the fixed frame as these terms. Now, it is simple algebra. You take the complex numbers, multiply, divide, and obtain the result. What I did is, in basic module, by the way, in MathCAD and MATLAB, you can perform complex number arithmetic and write this equation in a simple form. In case of Excel, there is complex numbers, but it is not that elegant. So what I do is, rather than solving this equation over and over, I wrote a simple function routine. You can follow this function routine very simply to determine the location of the pole in the moving frame, in the fixed frame, sorry. We first expand these equations in real and imaginary parts, determine the denominator, determine the numerator, and then multiply the denominator by its complex conjugate, and then multiply both the numerator and denominator by the same del, divided, and then you obtain the coordinates of the pole as A0 and A1. Pole is equal to A. It gives you the location of the pole. Let me show you how this is done. Any questions on this? Okay. What I will do is very simple. I'll turn on empty sheet. Okay. All you have to do is go to the developer menu, Visual Basic, usually file, import file. Import, I will go to basic. I think I should select read to basic one. I think I have shown what basic one is. It's for mechanism. No, that's new one. Okay. First, I will import again. Basic. I have shown what basic is. Basic is, usually this is what I use mainly: 4-bar coupler, 4-bar 2, slider crank, etc. Inverted slider, magnitude, and cos, and all these functions. You have to look what each one does. And in case of basic, there are lots of complex number arithmetic involved. Forget about CQF and I will show this function, pole function, Q1, phi1, Q2, phi2, and you determine the pole. Okay, that's it. Let me show how to use it. I have two positions. One is 10, 20, angle 20 degrees, X, Y, angle. I usually come over here, write pi over 180. Call that d dash r. Oh, I have dr over here. Okay, I forgot. I will not write that. I already have it as a function. This is, I'll call this point Q1. This is the angle. This is in radians, it is times d dash r, open close parentheses in this case. Q2, the second position, is 60, 100. Angle is 80 degrees. Okay, you can change it. I'll change it later. Let me first show what these two are. I'll take 5 minutes. Sorry, I'll call it A1. $10, $20. B1. $10 plus 5 times cosine this angle. $20 plus 5 times sine of this angle. What I have taken is I have taken another point on the x-axis of the moving frame, 5 units away from the origin, A1 or Q1. And let me write it over here. A2, B2. A2 is 60. Can I use any other point? Of course you can. B2 is 60 plus, again, 5 times cosine of the second angle, phi 2, is equal to this value plus 5 times sine of this angle, phi 2. This is just to show you the two positions, because visual interpretation is usually very important. Select data, x coordinates of A1, P1, y coordinates of A1, P1. Okay. Forget about the figure, because right now the figure will be a little bit distorted. Excel thinks it is clever, but it is not. It's a good tool, but it is not a clever tool. You must be clever. These are the two positions. The scaling is not correct. Looking at it, what I will do is I'll change the scale to like this. Format axis. Oh. 0 to 80, units of 20. And then 0 to 120, units of 20. Now, what I have to do is I have to see these grids as a square. I think that's correct. 5 units is not good. I'll take 10 units. Or 20 units, in fact. 20. Oh, no. That's better, right? I want to determine the pole. Where is the pole? Okay. Well, later on, I can do it. All you have to do is, number one, phi 1, 2, okay. This will be symbol. And phi 1, 2 will be, oh, it's class, okay. Subscripts. I didn't make these other Q1, Q2 subscript, but I will do it. Phi 1, 2 will be equal to phi 2 minus phi 1. Or in radians, it will be like that. P1, 2 I mark 2 cells. Okay. And formulas, user defined, go down P, O, P. Notice you have pole. Unfortunately, there is no help available for these cases. For Q1, mark these 2 cells. It's a vector. For phi 1, it has to be in radians. For Q2, mark these 2 cells. Phi 2, it has to be in radians. Okay? That's it. Control Shift, Enter. The pole, let me mark the pole. Select data. You see, you can select a point as a data, X value, Y value. This is minus 34, 103. Y is 103, minus 34. So I have to format axis. Then I have to move this. At least make it minus 40. Am I correct? Because it's minus 34. Here's the pole. Again, I have to make it square. This as a square. Now, if you want, add label. I'll show that as well. P12. Usually it is small. That's P12. I'm going to show it for this case. Add data labels. B1, do the same thing. Increase the size. If you want, make it subscript. A1, increase the size. Subscript. Then I think I made this too big. 14. Okay. You can do the same thing for B2 to show the case. Is there okay? Any questions on how to do this? I don't have to be bothered, but you have to know what P12 is and how to obtain P12. The pole, let me repeat, it is complex number arithmetic, that's all, to determine the coordinates of the pole. Okay?
Hocam.
Yes, sir.
What was phi12?
Phi12 is the angle of rotation. At the first position, the angle is phi1, 20 degrees. In the second position, the angle is phi2, 80 degrees. In that case, the amount of angular rotation for Q1 is, for that moving plane, is 80 minus 20. Is that okay?
Okay, so the second cell is in radians, right?
Yes, the second cell is in radians in that case. If you want, I think maybe I should do it like this. Okay? Now, once I do this, you see I can change, make it 5, make it 50. This is the beauty in Excel. Make it 17. You can change the position. You can, once you do this, you can find it easily, very easily, for other points. Okay? Any questions on this? Now, let me, can everyone see this, please? Let me take another problem. I'll add a sheet instead of opening a new Excel file. I have opened a new sheet. This time I'll take a problem, insert picture from this device, storage tank, no, A data. I think it was in here, yes. Here's a problem. I have a rigid body. Let us say a box is coming from one conveyor with top, bottom in front, okay, on the conveyor. Now you have to turn it over, flip it over 180 degrees and place it onto the other conveyor. The position of the two conveyors are 350 and 550 as shown, okay? I want to design a 4-bar mechanism to perform this task. Any questions about the problem? So what I do is, these are given to me. This is the given part of the problem. So I will select Q1, the origin over here, 0, 0. Usually I place my coordinate reference frame. If you want, you can place your reference frame over here or over here. I don't care. Maybe over here is you could do that. Okay, depends on what you want to say. How you want to analyze this. Depending on the person doing solving this problem, you can place your coordinate frame anywhere you like. Angle is 0. Y, phi. Let me make all of them center. Symbol. I will again change it to make it general. 0, 0, of course. Q2. Now it will be minus 350, correct? And 550, X and Y coordinates. Now it will be rotated 180 degrees. Pi in radians, correct? As I have done in the previous case, I will select A1. Sorry, I will use the letter A, B for my revolute joints, for moving revolute joints. So instead, I will use C1, Q1. Okay, I'll use Q1 and C1, Q2, and C2 for the moving body. Q1 is 0, 0. C1, I will take, if that is 300, 550, I will take 400 for the length, is equal to 400, 0. Q2 is equal to right? C2 is this value minus this value because it's rotated, flipped over. And Y is 550. Those are the two positions, okay? I have selected 2 points on this line and determine its location. So first, let me insert, first, add X, these two, Y, these two, okay, add I think this is sufficient to show the two positions of the moving frame. Let me repeat, you have to write A, B, etc., and you have to make sure that the scale is correct. Right now it is not. Oh, I think I have to do that. Make both sides 200. Okay. For the time being, it's okay. I will be changing them later. Maybe I should do it like this. Minus 800 will be better. Okay. Yes, I think that's good enough. Is that okay? Let me repeat. You have to label the points A, B, etc. But I'm not going to do that. It will take too much time. Then I will say, if I want to, I have done this before, so is equal to pi 2 minus phi 1. That's the amount of angular rotation. P12 mark these two cells. User-defined PR pole okay? And then Control Shift Enter. That's it. Let's come over here. Oh, not here. I'm sorry. X coordinate, Y coordinate. I'll mark this. I'll add the label. This is important. So, right. Okay. Now, what I will do is I will pick up 2 points on the moving body, A1, B1, as my moving pivots. Okay. Then I'll select A1. Looking at this figure, I will select A1 as, just for the hell of it, I can change it. I will be changing it 20 and minus 20. And I will select another point B1 as 300 x and minus 20 y. Oh, let me format axis starting from minus 200 to 600, because I will be using below. Okay, I think it's okay for the time being. If you want, I will select data. I can take point-wise, but what I will do is I will draw a line from A1, B1 to, from A1 to B1. Oh, sorry, okay. This should be minus 20 underneath the box. Okay, minus 20. If you want, I'll make it minus 30. Okay. One other thing I'll do is format data series. I'll make the color of those two black. If you want, you can increase the thickness. That color, I'll make it red. To show that the two are the same positions, on the same rigid body, in the first position, in the second position, okay. Now I have to determine A2 and B2. Am I correct? How can I determine A2, B2? Can somebody recommend me something? I know the pole. Okay, now what I can do is, if I refer to, sorry, over here, the distance C1, P12, A1, P12 is equal to A2, P12, or C1, P12 is equal to C2, P12. So I obtain C2, I can obtain C2 by rotating this vector P12, C1 by an angle phi 1, 2, it will be at C2, correct? This is exactly what I will be doing. What I will do is, first of all, I will determine over here, I will determine P12, A1 distance, A1 vector, P12, A1 vector. That will be equal to A1 minus A2, x coordinates. And if I move it like this vector is from P1 to A1, this line vector, P1 to A1 vector. Z grid, x coordinates, y coordinates. The magnitude of this vector is equal to, I can write square root of this value squared plus that value squared, mag function, magnitude, this value, comma, this value. That's the magnitude. That is the distance from P12 to A1. angle is equal to A tan 2. I have to determine the angle. I have to use A tan 2, otherwise I will not have the correct quadrant. Open up parentheses, or I can use another function, ang function. Can you see that? Ang function. Open up parentheses. This value, x component, comma, y component of this vector. It is the angle the vector makes, conversion from Cartesian coordinates to polar coordinates. In radians, what is this in degrees? This value divided by d dash r. Oh, I have to, okay, 303 degrees. As you can see, this angle makes 303 degrees from the positive x-axis. Any questions? X component, y component, angle, radians, sorry, no, magnitude, sorry. Angle, and then degrees. In radians, in degrees. Can I do the same thing for P1 to B1? Repeat the same process. This value minus this value. I'll show you. Okay, if you press F4, fix the pole, okay, over here, and fix the pole over here. Look, it is B1 minus P12. X coordinate, B1 minus P12, Y coordinate. And magnitude, the same thing. Angle, I don't have to type all those again. Is that okay? Now, A2, with these values, I have all set. A2 is equal to, please remember that, P12 plus this vector, P12, C2, correct? Now, is equal to x coordinate of P12, x coordinate of A2 will be x coordinate of P12, plus this magnitude, P12 A1 length, which is the same for P12 A2, times the cosine of the angle in radians. That is the angle phi 1 in the first position of that vector. To that, I will add phi 1, 2 in radians. For y coordinate is equal to y coordinate of P12 plus magnitude of P12 A1 times sine of the angle for the first position. To that, I will add phi 1, 2. Okay? Now, as before, if I mark this as fixed, the coordinate of P2 as fixed, if I pull this down and pull this down, that's it. Let us see whether we have made a mistake or not. Add x coordinates of A2, B2, y coordinates of A2, B2. Yes, I have made a mistake. C6, that's correct. G10. That's correct. Sine of H10. Oh. That should be C5. Oh. No, I'm sorry. This should be C6. This should be C5. Angle has been P1 to Y coordinate. Okay, that's, I'm sorry, I goofed. Again, I have a mistake. See? B6, I make the same mistake. Okay. Can everybody see that? Let us check. A1, let me take 0, 0. Yes, that's correct. For that, I'll take 400 and 0. That's correct. Now, these are given. These positions are given. Let me mark them as yellow. These 4 values, I can select arbitrarily. Let me mark them like that. A2, B2, once I select A1, B1, notice A2, B2 is fixed. Okay, I think I'll give a break in 7 minutes. In 7 minutes, I will give a break. Now I have to select A0. Can everybody see that? I have determined A1, B1. I have selected A1, B1, determined A2, B2. Now I have to determine number 1, perpendicular bisectors. Number 2, a point on the perpendicular bisector. Correct? Arbitrarily. Now for that, I will determine if these are my moving pivots, A is my, and B are my moving pivots, I have to determine the midpoint of A1, A2 and determine the angle A1, A2 makes, correct? Because A12, the perpendicular bisector, is going to pass through P12 and make an angle perpendicular to A1, A2. So let me determine, I will call it theta A, This is the angle made by A1, A2 with respect to the positive x-axis. It is equal to A10 to, open up parentheses, open up another parentheses, A2 minus A1 x coordinates, comma. In some of your computers, it will be semicolon. A2 minus A1 y components, close parentheses, close parentheses. If you want, you can use ang function as well. A102 is Excel built. Ang function is user-defined. Correct? This is the angle made by A1, A2 with respect to the positive x-axis. Is equal to this value divided by dr, 123 degrees, which is correct. Correct? Now, the perpendicular bisector is going to be perpendicular to it. So it will be either plus 123 degrees plus 90 degrees or 123 degrees minus 90 degrees. It doesn't make any difference. I'll show you that. Theta B if you have done it correctly, you can pull this down. Check your results. Due to this relative referencing command, it is the same. It gives you the theta B. The angle B1, B2 makes with respect to the horizontal. Correct? That's it. Now, in order to show I have one point on the perpendicular bisector, I know all the perpendicular bisectors are going to pass through P12. I will draw a line like this. Let me take some length. Over here, I will take 500. These will be 2 points on the perpendicular bisector. Sorry, I will write A12, that will be better. A12, I will select 2 points on perpendicular bisector A12. One will be P12 plus 500 times cosine of this angle plus pi over 2 is equal to P12 y component plus 500 times sine of this angle plus pi over 2. Okay? And the second component, I will look, I'm copying it like this now. Control C. Control V. I have copied the formula itself. Change this to minus. Control C. Control V. I have copied the formula this time. Oh, I have two pluses. Minus. Okay. Now let me draw that line. This is the perpendicular bisector to A12. That's the perpendicular bisector to A12. What I can do is, oh, sorry. A12. Okay? Ah. Ah, now I got the way. Now, if I don't, I have done it correctly, I can B12. Let me fix some certain cells over here. Number one, I'll fix this one. This one. That's it. These are fixed for B as well. That's why I'm doing it. Control C, Control V. I have to check. Yes, that's good. That's wrong. It says move two down. Now it is correct. Okay. This seems much simpler than typing the whole formula again. Again, I'll take select data. Don't worry. There are plenty of you can draw plenty of lines, as many as you want. Maybe if I reduce to 400, oh, still just too far off. Okay. Add data label. Okay. I think I'll stop right now for 10 minutes or 15 minutes, let us say. If you have any questions, I will be here. You can ask, but if you want, I'm not going to continue for 10 minutes. But I'm here. You can ask me any questions you like. Anything that you haven't understood, please ask. I have stopped.
Hocam pardon.
Yes, sir.
Soru sorabilir miyim şimdi?
Of course, of course.
Bu bisector'ları sonsuz doğrular olarak çizmemizin bir yolu var mı?
I don't understand.
Ya buradaki çizdiğimiz bisector'lar doğru parçası olarak çizildi ya.
Uh-huh.
Ya işlevsel olarak bir şey fark etmiyor aslında ama bunu yaparken direkt doğru olarak çizmemizin bir yolu var mı?
Oh, you mean infinite lengths?
Evet.
In Excel, I have to have a finite length. You see, I can change this to, if you want, I can change to 10,000, and you'll see within the drawing, it will be infinite. Is that
Tamam
okay?
hocam. Yes.
Increase this length. What I have done is I have taken 400 units to the right and to the left of P12 this time.
Okay.
Is that okay?
Yes hocam. Sağ olun.
But if you want, you can, to make it infinite of any length, make it, a million. I don't care.
Tamamdır hocam. Sağ olun.
That's the only way I can tell you. 10 dakika ara verdim arkadaşlar. Yani sorunuz varsa soru cevaplayabilirim. Cevaplamaya çalışayım. Kaydı. Recording nerede ya? Resume. Okay. I'm sharing. First, let me explain it. You see, what we have done up to now is very simply stated. We are given the two positions. Outgoing from the two positions, we determine the pole. And then we select 2 points, A, B, on the moving frame, the first positions of which are A1, B1. We select them. And using these, we determine A2, B2. And then we determine the pole first. We then determine A2, B2. The second position of AB. Then we determined the perpendicular bisectors A12 and B12. Now we have to select a point A0 on A12 and a point B0 on B12 to form a 4-bar mechanism that will move this rigid body from the first position. That is possible to move this rigid body, let us say. That would be more correct. To move this rigid body from the first position to the second, or from the second to the first. Now, I can do this in 3 different ways. Number one, I can select a distance S from the midpoint of A1, A2 and locate A0. I have a parameter S that I will select. Number two, I can select P12. From P12, I can measure a distance S. That's also possible. But much more meaningful than these two, you can do that very easily. More meaningful than these two is I can select the distance A1, A0. The link length, the crank length I can select. According to this crank length, I can determine A0 either here or here, above or below, because if I draw a circle, it will intersect into 2 points. I can select that. And then locate A0. To do this, notice this distance S is equal to A0, A squared minus A1, A2 over 2 squared. This is the hypotenuse of a right triangle, as you can see. A1, M, A0 is a right-angled triangle, and A0, A1 is its hypotenuse. So I can determine S. Outgoing from S, I can determine A0. Now, I will use this condition. I will select A0A length as my free parameter. I will select an A0A length. Okay. This A0A length, remember, keep in mind that it has to intersect that perpendicular bisector. If I select it as 200 units, for example, A1, this is A12, I don't think I will be able to reach that. So I will select it as, shall I say, 400? Let me repeat, you cannot select anything because if it does not intersect A1, A2, A12, perpendicular bisector A12, there's no solution. If I select A1, A0A as, sorry, something happened with, 1 second, please. Okay. So I will select it as 400 units. Later I can change it. Of course, this is a, let me repeat, input. I've made it pink. But before determining the distance S, I have to determine A1, A2, right? A1, A2. Is equal to magnitude, mag, open up parentheses, open up another parentheses, A2 minus A1, comma, open up parentheses, A2 minus A1. Oh, I forgot another third parenthesis. Okay. So the distance S from the midpoint to A0, when A0A is given, is equal to SQRT, open up parentheses, 400 squared, minus, open up parentheses, this value divided by 2, close parentheses, squared, close parentheses. Okay? S is 186 from the midpoint. So A0 coordinate is, first of all, it is the x coordinate of the midpoint. It is A2 plus A1, close parentheses, divided by 2 is the midpoint, plus S, the length S, times cosine of the angle theta A, A0A makes with respect to the horizontal, plus pi over 2. Is that okay? Now, B12 plus B9 over 2 is x coordinates of A1, A2 held. It is the x coordinates of the midpoint of A1, A2, which is on the perpendicular bisector, by the way, plus the distance S from that point to the center point A0 on the perpendicular bisector, and the cosine of the angle the perpendicular bisector makes with respect to the horizontal. It is the angle theta A, A1, A2 makes with the horizontal, plus pi over 2, because perpendicular bisector is 90 degrees. Is perpendicular to is 90 degrees to A1, A2. Correct? That is, you will give me the coordinate, the x coordinates of A0. And the y coordinates of A0 is, again, I have some other shortcuts, but I'm not going to do that, is equal to the x coordinates, y coordinate of A2 plus the y coordinate of A1 divided by 2 plus the S length times the sine of the angle theta A plus pi over 2. Correct? Close parentheses. Let me write A1 over here. To show the 4-bar originally. If I have done everything correctly, A0 will be on the perpendicular bisector A12. Let us do that. Let us see. Select data. A0, A1. That's 1 point. If I select 450 instead of, if I wanted to select it on the top, at the top, all I have to do is change this plus sign to minus sign. Over here, if I change this plus sign to minus sign, it will be on both for X and Y. It will be on the other side of the midpoint, okay? Now I will repeat the same process for B. Again, I will select B0B. B0B will be a little bit bigger, 600, let me say. Let me repeat. These values I will be changing. I'll show you how to change these in a minute. And then B1, oh, sorry, I'll cheat a little. Control C, Control V. This is easier. B, B, B1, B2. Oh. If you start using mag, etc., it makes life easier. Okay, I mean that's all. I mean, if you want, you can write square root, square, etc., etc. But rather than that, I prefer to use these. Okay, and S for that is SQRT, open up parentheses, this value squared, minus, open up parentheses, this value divided by 2, close parentheses, squared, close parentheses, okay. B0, B1, we are almost done. B0 will be equal to the midpoint, open up parentheses, B2 plus B1 divided by 2 plus S times cosine of the angle theta B plus pi over 2. Let me check. Yes. And y coordinate, let me show something else. Control C. This is something I usually use. Control V. This is the same formula. But I have to change certain things. Number one, I have to change B1 x coordinate to y coordinates. Number two, G24 is the same. Instead of cosine, I have to change it to sine. Sometimes I find this much simpler to do. That's it. And then Here is a 4-bar. I can change lots of things. I have 6 parameters, notice. X and Y coordinates of A and B. The length A0A and B0B. If you want, I can change this B0B to 750. 450 to 500. Okay. I can assure you that this mechanism is going to be movable in between the positions. Okay. Let me do it like this. Yeah, I think I will do it like that. Move this one down, and these 2 cells one down. Write B2, sorry, A2, right over there, A2. B2. Correct? Now, what I will do is, this is a simple trick. Pull this series up 1 so that it includes A2, B2. Okay? Sorry. Yes, the mechanism does exist at 2 positions. Can you see that? But is the motion possible in between the 2 positions? You have to check. Now, the result is our vectors. I have all the necessary data to draw this mechanism. Now I have to animate this mechanism, correct? The 2 positions do exist, as you can see. I can make lots of changes, but I'm not going to do that. This 400, let me make it to 500 so that what's it? Ah, that's good. B13 is way down. Okay. Now I have to animate this mechanism. Correct? Now, for the animation, number 1, I know the link lengths A0A, B0B, I know these lengths. I have to know A0B0, correct? A0B0 length. A1, B1 length, AB length, I have selected as over here 400. I know that. No, I haven't selected it. I can determine that length from here. Okay. Now, first of all, let us determine the magnitude of A0, B0. That will be important. The length A0, B0 is magnitude, open up parentheses, the x-coordinate of B0. Oh, I forgot the equal sign in front, so it doesn't take it as a vector. Magnitude of B0, x-coordinate of B0, minus the y x-coordinate of A0, close the parentheses, comma, open up parentheses, y coordinate of B0 minus the x coordinate of B0, y coordinate of B0, sorry. I forgot the second parameter. It's okay. That is the A0, B0 length, this length, 231. The angle A0, B0 makes with respect to horizontal, I'll show you another trick. Take this, copy. Firstly, I will write it like this. Angle X A0, B0. This is magnitude. Change it to angle. Like this. Or if you want, you can use A tan 2. This angle is (477 degrees). Let me show you something, 277 degrees. If I have used ang. Let me copy this again. Control C. Control V. Instead of ang, if I type A tan 2, that is a built-in function for Excel. Ang is what I have written as a user-defined function. A tan 2 with the same arguments is going to give you this. This is going to be different. Why? If you add the 2 up, minus 82 degrees, 277, or this value minus this value, as you can see, it is 360. The difference between ang and A tan 2 function is, in one case, I found it in certain cases this is useful. A tan 2 function gives the angle from minus 180 to plus 180. If the angle is in the third and fourth quadrants, it is minus. It gives the negative sign. In my case, for ang, I said, okay, let me have from 0 to 360. Okay, all positive. That's the difference. But you have to know that the difference, okay? You can use either one. They refer to the same angle, no problem. But you have to know the difference. Okay, when using it, be careful. Now I know the link lengths. Oh, let me say AB length. AB, I haven't calculated it, so same thing. Equal to magnitude, open up parentheses, another parentheses, B1 minus A1, comma, B1 minus A1, comma. It's going to be 280, if I'm not mistaken. Okay? Now you know the link lengths. You know the angle the fixed link makes with respect to the horizontal. You have to know one other thing, and that is which link are you going to use as the crank? Are you going to use A0A as your crank or B0B as your crank? Depending on the problem, depending on which one will be possible. I think in this case, B0B will be the crank. Otherwise, if you use A0A as the crank, you will not achieve the motion. Okay? So I will use B0B as my crank. Okay? Can I ever see that? You have to use B0B as your crank. Otherwise, if you use A0A, there's a dead center in terms of that. So it will flip over. This thing will go back. It will not be able to. No, it's no. A0A is correct. Let me do it. A0A. I'll use A0A as my crank. So what I will do is, I will determine the angle θ1 and θ2. Not sure. Okay, I'll check it. The initial crank angle A0A1 will be equal to A10(2) and A10(2) will be better in this case. Open up parentheses, open up parentheses. A1 minus A0, comma, it is minus 11 degrees with respect to the horizontal. And then for minus 11 degrees, θ2 is equal to, or sorry, A10(2), A2 minus A0, comma, B2 minus, sorry, A2 minus A0 y components. (78 degrees). Correct? So the angular rotation will be from minus 11 degrees to plus 78 degrees. Can everybody see that? I have A0, B0 making an angle 277 degrees. Okay. I want you to think, how can I determine the four-bar mechanism? Now I have completed the synthesis portion. Now I have to analyze my mechanism. I know all the link lengths. I know that the crank is has to move from minus 11 to plus 78 degrees. Okay. Now I have to animate for any angle theta. Okay. Let me write over here. I don't want to go down. Usually I go down, but or then writing analysis will be much better word. Analysis. I will select a certain theta angle. Let me do it this way. First, I will say d theta, the amount of angular rotation. Is equal to this angle minus this angle. Then I'll divide this to 90 degree, 90. N is equal to 2 or 5, just for the hell of it. I will do it like this, is equal to initial value plus 90 divided by, let me say, how many degrees? I will select, I think 20 is good enough. 20 by this value. Is equal to this value times dr in radians. You see what I will do is, if I change this 5 to 0, it will be 11 degrees. If I change this 5 to 20, it will be 78 degrees, okay? I have divided the interval to 20. Okay, keep it like that. I have to rotate this A0A vector by a certain amount. Okay, I can, now I know A0A, initial crank angle A0A, and the amount of angular rotation theta. Now I can determine A0A. I want to determine the position of the other links. Can anybody think of some way to do that? Can you think of something from 301? This is analysis. There's nothing, it is the analysis. I have A0, B0. I have the crank position. Yes, any idea? I know all the link lengths. I have determined all the link lengths. I know A0A, I know B0B, I know A0B0, I know AB.
Hocam, are we going to define a point that can move
yes,
as
yes.
B by using
A and B?
Link? Yes. So maybe we can start with the point A0 and using the link length A0A and the angle theta, we can define that point.
That you can do.
So
you can determine A1. Well, how are you going to determine B1? If you determine B1, the problem is solved.
Like when I look at the diagram now, the angle theta looks like is valid for both of A and B, but I'm not sure.
You see, what I can do is, if you look at this diagram, I know the position of A. I can determine the position of A. What I can do is, I know A0, B0, and I know the angle it makes, etc., everything, okay, about A0, B0. I can determine the distance from B0, remember the triangle? B0 to A, correct? This A0A has moved somewhere. I can determine the distance B0A for that position. You're solving this triangle. B0, A0, A. Okay? A is not here, it's somewhere here. Okay? First I solve that triangle, and then I solve the other triangle. That's one possibility. Correct? Or else, I have shown you the 4-bar function that is available in Visual Basic basic program. Here is the 4-bar function. As I will be using 4-bar 2, crank, coupler, rocker, fix, config, theta. This is the 4-bar function. Now, that 4-bar function uses this A0, B0 as your x-axis. The input crank angle has to be measured from that axis. Correct? Can everyone see that? Once I do that, I determine these angles from the A0, B0 as my x-axis. Agreed? Right away. Now, this is the angle from this position. Okay? This is the angle, the rotation from A0, A1. I have selected this angle as the angle from A0, A1. The angle A0, A1 makes with respect to B0, A0, what is that angle? Look over here. B0, A0 makes an angle 277 degrees or minus 82 degrees with respect to the horizontal. And A0, A1 makes an angle minus 11 degrees with respect to the horizontal. So what is this angle? This angle is equal to A0, B0, sorry, B0 angle B0, A0, A1. That angle is equal to theta 1 minus 82 degrees, 70 degrees. Can everyone see that? It is this angle, 70 degrees. If I add this angle theta, 10.9 degrees for fifth position, and this angle, I come up with a certain position, right? At a certain position. Agreed? Now let me repeat. Oh no, that angle I have added to the G11, so I have to forget about this. That is the angle. If I do it like this, this is the angle from this position. Okay, I'm sorry. To that, I have to add this to obtain the location of that of A0 at that position. Now, all I have to do is look. Mark these two cells. Formulas, again, function insert. F, 4-bar 2. Crank. What is the crank? A0 is my crank. Coupler. Coupler is A1, AB is my coupler. Rocker is B0B is my rocker. Fixed is A0, B0 is fixed. Config, if I'm not mistaken, it should be 1, but we'll check. And then the angle theta. I have to measure the angle theta from A0, B0. The angle A0, B0 is, since I have all these two in radians, this angle, the A0, B0 makes with respect to the horizontal, plus times dr, open close parentheses, plus this angle in radians. Correct? Now you have the result. Control Shift, Enter. But these two angles are not measured from the positive x-axis. These two angles, one is theta 1,3, the other one is theta 1,4. These two angles are measured from A0, B0. Let me show in radians, in degrees. One is 59, 99 degrees. Let me show one thing. If I make it 0. This is something, if I had it 0 and 0. Oh, yes. Now, notice, theta 1,3 is 82 degrees, theta 1,4 is 92 degrees. Whereas theta 1,3, notice, is horizontal. Am I correct? 2020 is horizontal. Now, please look at this 82.27267 and this angle. So what that means is you are measuring it from A0, B0. Now, you have to subtract, in this case, minus, if that is 82 degrees, you have to add, this amount, Control Shift Enter. Now you have the correct angles for theta 1,3 and theta 1,4. Theta 1,4 is 9.95 degrees. Theta 1,3 is 10 to the minus 15. As far as I'm concerned, is 0. Is that agree? Can I see that? So let me take it 5. Now I can very easily draw my 4-bar. A0, A, B, B0. A0 is fixed. B0 is fixed. A is A0 length. A0, first A0. Plus, to that, I have to add A0 length times cosine of the angle. This angle is plus theta 1. Am I correct? Yes. Yes, that's correct. Is equal to A0y coordinate plus A0a times sine of this angle plus theta 1. B is equal to B0 plus B0b times cosine of the angle theta 1/4 directly is equal to y coordinate of B0 plus B0b times sine of the angle theta 1/4. Let us draw our mechanism and see whether it works or not. I think I have to make it more square again. I'll make it one piece. Next, go to the developer, insert, properties. This time it is very easy, from 0 to 20, units of 1, that's good enough. Okay, in cell J23. J23 is the linked cell. Let's see. Yes. Hmm. I thought I divided it to 20. Oh, sorry, it doesn't work. B0, A0A being the crank does not move does not rotate your the 4-bar to the second position. As you can see, my result is wrong. Okay. As you can see, it works, but it doesn't satisfy my requirement. I have to flip it over. Let me show you the, I don't have time for the other case, but I'll keep this, save this, save as. I'll write true posts in class. Oh, if you have Excel sheets, click no. Excel macro enabled, you have to save it as such. Okay. I will show you the same thing. I hope I can find it. I think it's this one. No, it's a different solution. For 180 degrees, I have this solution. Yes. This solution, this is the same thing, but I'm sorry. I am not selected the correct one, correct AB. So the procedure is the same, but you have to redo it. As you can see,
Hocam, can't we fix that mistake by changing the limits to the angle theta?
I'm not sure if, let me see which crank I have used. I think I have used, again, yeah, you can do that. But I have to, for example, in this case, A12. This time I have selected something. You see, as I said, you can select different parameters for A0. I'm not sure. Link to, no, this is correct. But the positions are different. 0, 0, 350, 500. No, I have used that. P12 is the same. 2050, 280, 50, 45, 63. You see, if you place click, you can change the position of A0 and B0. Yes. You see, I have called this, in this case, I have called B the first point, A as the second point. I have used A0A as the crank. In my case, I had to use B0B as my crank. That's what I said. Okay, I'll post this as well. Okay, so you can, if you want, you can change that as well. Okay. I haven't done anything wrong. Let me repeat, I have not done anything wrong, but I have selected my crank different. So in that case, it doesn't move to the second position. That's all. You have to check. Is that okay? I'll post this one and what we have done in class, I'll post it as well. Okay, you have a homework to work on for this topic. It is very powerful. You see, I haven't done it, but let me show you. Since you can select your moving pivots, anything, that's free. For those parameters, you can place the click button so that you can change the location of that A0A, B0B, anywhere where you like, as you can see. You can change the X and Y coordinates. Of course, these have to be in certain limits, depending on the problem. You cannot, I think you already know that, you cannot, simply select them. You can change link lengths. Okay, to obtain different solutions. I'm not going to save this. I will send you the origin. Don't save. Any questions, please? Let me read. I had to select B0B to make it rotate 180 degrees. Right now, for this case, it doesn't rotate 180 degrees. But this is the analysis. Very simple. Any questions, please? I stopped sharing. I will stop recording, but where the hell is recording?